Hello Internet! Today we're going to be going back to Asteroids VR, and what I wanted to work on today is sort of an experiment around how we might build an asteroid belt. So we've done these in the past, and a lot of the focus has been on like instancing the asteroids so we can have a lot of them. What I want to focus on here is how we're actually going to move them. And so one of the things that I kind of want to talk about is sort of matrices and why they're so awesome. If you've used graphics stuff, if you're familiar with graphics stuff, you might be familiar with vertex shaders. And the way vertex shaders work is they take a point in object space, translate it into world space, translate all the points in world space into screen space or into some sort of space that's relative to your camera, and then maybe do some sort of perspective so things that are further away look smaller. And all of those parts are handled by different matrices. And so the cool thing with that is you can have one matrix for, say, your world space change, and it will take any object and translate it into world space. And so you can just kind of bubble that up. So what I'm thinking is to kind of illustrate what that looks like, if I create sort of a tree of game objects here, like I have a game object, a game object child, and then a sphere at the end, we can sort of move these objects relative to one another, and we sort of just have this arm thing going on. And I can rotate the sphere, and that's fine, and the sphere rotates, but the rest of everything else doesn't because it's a child. But if I go up the graph, what ends up happening is the sphere gets multiplied by its parent's matrix. It's transformed this information up here in the top. And so by moving up that graph, we're actually just adding another matrix to the stack. And so when I rotate this one, we rotate, oh, that's not the right one. We rotate around a different axis, somewhere in the middle there. And if I were to go to the parent and rotate again, we rotate around that parent's axis. And so it kind of stacks. And so what I'm thinking is we can have one sort of rotation matrix and multiply all of our asteroids by that, and that will get us a general spin. And obviously some things are going to have different things to that, but that might be a good way to at least get general movement. So we have sort of a uniform thing, and then we can add chaos afterwards. So maybe not everything needs to be chaotic, and we can have most things just kind of follow a set path, or one of a few paths. So that's sort of the idea. The cool thing is, it's just a matrix. We're doing this all with like Unity's transform stuff, or maybe you're doing it in shaders with vertex shaders and things. We don't need to do that. We can just use a matrix. And so that's sort of what I want to explore here, because I haven't really done it. And so I've created this asteroid belt test script. I'm just going to add it to our game object. I think I added 2 now. So let's remove the second one. And we'll just go into that. It's totally empty. There's not much there. We can get rid of that. And so the first thing, we're going to have a public int points equals equals something. And so we previously talked about on validate. So void, public void, there we go. I'll spell public right eventually. On validate. And so this is a function that's going to get called every time we change something in the inspector. And so it's sort of a way to validate things that you're entering through Unity's UI, but it can also do other things. So what we can do here is when we change our points, we actually want to regenerate a series of points in a circle around this. That's sort of the idea here. So public float length. So if we change either of these two values, we need to regenerate our set of asteroids. So we're just going to have a private list of vector 3s. And so this is just going to be points of asteroids. That's all I'm going to store for now. We can also use this to, say, modify the rotation and the heading of these things, but we're not going to do that right now. Instead, this is just going to be the asteroids. And so here, we want to generate a set of these. Need to remember, there we go. Trig stuff. Let's do a for int I from 0 up to our points. that's not how we do that. I plus plus. Let's see here. Well, I is less than the number of points. Increment I and do this thing. And so we want some sort of vector here, or some sort of ratio. So I'm going to reduce this I and points into 0 to 1, where I equal to points is equal to 1, and that will be like a full loop of our circle. And then we can just use that as sort of our reference point. And so we can just do that. Float ratio equals the float of I divided by the float of our points, like that. And so now we have 0 to 1 for, what am I thinking about? For circles, we want anywhere between 2 pi. So we can just do ratio times equals 2 times mathf dot pi, like this. And so this is going to get us somewhere in radians around our circle. And then we have to create the point. So asteroids dot add a new vector 3. We're going to do it on the xz plane. So mathf dot sine of our ratio, 0 for the y, and then mathf dot cosine of our ratio. This doesn't have our length, so after we create that vector, I'm just going to multiply it. This code isn't optimized at all. And so it's kind of meh, but that's not the point here. This is probably never going to end up in the actual project. It's more of a way to test this and see how it works and if it's what we want. And if we're right, then we can fix this up and figure out a better way to do this. Because I don't know what the actual solution looks like. I just kind of want to explore this. So that's what we're trying to do here. But that should be it. The only other thing that we really want to do is create a new list of vector 3s when we call this on validate. Otherwise, it would never get initialized and everything would break. And we don't want that. So there we go. On validate generates the new thing. And we will also do the same thing in our public void start. Let's put it in the awake. So the difference between awake gets called when you instantiate things. Start gets called immediately before the first update of the object. And so awake should always get called first. And generally, I think is better. I don't honestly know. So maybe not the best advice, but I'm going to put it in an awake because that makes sense. And because we don't care, I'm just going to call on validate. That's probably not how we want to do this because it's actually going to cause validation of our things. This function should be moved somewhere else, ideally. But I'm going to leave it there. Just because it's sort of a scrappy function. Trying to get it all to make sense and be a good code, it isn't the best use of time, I guess. So we're just going to pretend like we aren't going to do that. And then the final thing that I want to do is public void on draw gizmos. And so the idea here is we want to actually draw these asteroids because we don't yet. So first we're going to make sure that we actually have some. So if our asteroids is not null, then for each asteroid in our asteroids, let's do a gizmos.color equals color.red, green, blue, red. Sure, we'll do red. And then a gizmos.draw sphere. And so this will just draw a solid sphere at a point, and we can just give it our asteroid as the point because it's just a vector. And we'll do 0.5 for the width. And so that should draw our gizmo. We have the validation and the awake. So that should cover both initializing it when this is for initializing when we start the game. And then on validate is sort of an editor script. So as we update the number of points, we should see them pop up immediately in Unity's editor. That's the goal there. That's why that whole thing exists. It's not strictly required. It's just sort of a nice way for you and for me to be able to see what's actually happening, because we don't necessarily know what's going to go on. At least I don't know what's going to go on. So we have nothing here, 0 points. It should have compiled. So as I increase this, we get a dot. And then we've increased it to, let's do 42, because that's the answer to everything. And then increase our length, and you can see it just fans out for us. And so that's sort of the power of onValidate. That's a pretty handy use of it, I think. And so there we go. Now we just need to actually rotate this thing. And so that's the next part. So really, unless we want to do this, I don't know how to do this in the editor, like have it constantly look like it's updating in the editor. That doesn't actually seem useful either, because we already have the circle going, so it doesn't make much sense. So I'm just going to do it in the update here. And what that's going to look like is we need a matrix. So a matrix 4x4 .trs, which stands for transformation or translation, rotation, and scaling. It says it right in the documentation. That's handy. And so we don't care about the translation. Translation is going to be literally moving something forward, backwards, side to side, up, down. It's sort of your position. Your rotation is the physical rotation, so the yaw, pitch, and roll of your object. And then the scale, if you want to like expand this or shrink it back down, that's what the scale would be for. So yeah, when we're talking about scale here, because we're working with vectors, it won't make them bigger. Like it won't make your asteroids bigger. It will just make them further apart, because it's expanding those vectors, not the size of them. So anyway, vector 3.0, our quaternion will be we'll come back to that, because this one is also just a vector 3.1. Has to be 1 here. If you put a 0, everything's going to be back at the center, because you scale everything down to 0. And so here, let's do a quaternion dot Euler, and we'll just rotate on the y-axis, so that will spin everything around itself. We can change this later, or we could get even more fun. Let's do a rotation vector times the time dot delta time. And when we do this, we can insert this public vector 3 rotation vector. And so I can just set this to 1, for example, and we'll rotate around that. We'll rotate around the y-axis. But I can also change it, and if we want to like skew it or something, we can make it wobble or whatever we want. And so hopefully that results in something interesting other than just boring. And that should be all we need for the update. Well, hold on. That's just creating the matrix. There's a whole bunch of other things we need to do. So I should probably do those. So our matrix, there we go. And then really what we need to do is just update these set of points. And so I think the best way to do that is to do asteroids equals asteroids dot select. Hold on. I want link for this, I think. Link probably, yeah, it'll be fine. Let's use link. So link is a fun little C# library for working with collections. It's awesome, but not necessarily performance is like your top thing. But yeah, it's just there's other things that I'm not going to get into here, and I just don't want to deal with, that might make it less good for this kind of thing. But for what we need to do, it's going to make the code real nice, I think. And so really what we need is just a select. Select is going to be, say, given a value, return this other thing. And so we're just going to give it our current, or we'll call it the last, and we'll return the current value. So the last thing is going to be that, and we're just going to do our matrix times the last value. And I might not like that because I IEnumerable vector 4 to vector 3. So we need to create this as a vector 3 because the matrix 4x4 is a four-dimensional matrix. We can't use that. So we need to create a vector 3 out of it. And I guess we're going to do it this way. Vector 3. Does that work? No? That takes one argument. Okay. That's too bad. Well, we're going to do that, I guess. And then we're going to make it a little bit harder. That's unfortunate. There's probably a good way to convert from vector 4s to vector 3s, but I don't know it off the top of my head, so we're going to do it the brute force way. So our current position is this. And then we want to return a new vector 3 of our current.x, current.y, and the current.z. And that's it. Why doesn't it like that? Oh, so what we're doing here, link is all sorts of overloaded functions on top of IEnumerable. That's the error we're getting here. Cannot explicitly convert type IEnumerable to list. List is a supertype, not a super, maybe. Don't remember off the top of my head, but list implements IEnumerable. So a list is an IEnumerable type, but an IEnumerable type is not a list. Not necessarily. They can be other things. And so we need to actually make sure that this is a list because our thing says it needs to be a list. The alternative is to actually just make this an IEnumerable, which should also work. And the only issue is we'll miss this add here. I don't actually want to do that though. So we're just going to do toList at the end here. And so there's a few extra things that happen with toList when we're talking about this. Link is lazily evaluated, which means that it's when I write select, at the end of that function, nothing happens. The only time that it's going to get evaluated is when we actually iterate through it. And so part of the issue with link is if I were to leave it like this and ignore that error, if I were to suddenly like do for each asteroids something to kind of iterate through that, and then somewhere else also did this, or maybe didn't update this every frame or something, if I had two of these, what would end up happening is we would do this select twice. And we don't want that, and two, that's just slow, and we're just doubling up stuff. It's not great, and so that's just part of the way link works, is being lazily evaluated. The cool thing is you can kind of set up your function and then call it when you need it. But there's some other things. I've done a video on link, so if you want to go down that road, go for it. It's for the most part, you're not going to run into that kind of stuff. But if you do, just remember it's lazily evaluated. So yeah, just beware. Anyway, toList solves that because it actually forces an evaluation and returns a concrete thing. None of those lazy things are going to exist anymore. So that should solve that. Tangent on link. Cool. So now that we've done this, if I start it, well, first let's actually get this rotation vector. Let's just set it to 1 for now. And so this should be very slowly rotating around because it's going to be like a fraction of a degree around this. We may need to increase our rotation vector. So go here, and you can actually see we do have this thing spinning. I'm actually going to trigger this and just increase it. And now you can see it's all rotating. And so that's matrices. I suppose that, yeah. But that's sort of what we're going for. We can use this to kind of rotate everything, just give it a single matrix and force everything to rotate. And some of these we can kind of select and add some extra forces to, or maybe only simulate the ones more cleanly, I guess, with more physics and things when they're close to the player, because this is going to be a very big thing, like it's going to circle a planet. And after a certain point, you're not going to be able to tell if things are doing this or if things are actually moving more erratically. And we can also, because we can just change this rotation vector, I can add some wobble to it. And so this is the result of that. But you can kind of just explore this. It's matrices. And so if you're curious about like how shaders work, for example, this is part of it. It's not all of it, but matrices are a really big part of what makes shader magic happen, because this whole translation, rotation, scale thing is effectively what gets you from a point of a sphere or of whatever your mesh is into world space, into your scene. And then from there, there's a few other matrices that kind of do some other magic to get you to what we're seeing right now. So that's that. I'll leave it here because that's sort of what I wanted to do. And this kind of gets us to a fun little point. I think we can probably use this. So that's it for now. I'll see you guys in the next video. So until then, see you, Internet.